Okay, thank you very much, both Dr. Wilcox and Dr. Nicholson for really helpful presentations. I want to invite you back now, if you can join me here. Hi, Simon. Hi, Jen. And I want to remind our participants that we have a Q&A box, and I have some colleagues that are helping me monitor that Q&A box and think through questions. So please do submit some questions there for consideration. So Jen, in your excellent presentation, you mentioned that the energy requirements for DACCS may be high. So indeed, it's even been suggested that 1 gigaton of removal could consume a quantity of energy approaching the total electricity generation for the US in 2017. This is from a Sakara paper. Could you reflect a little more on the claims that some have made that energy demands would put DACCS kind of out of reach, or others that argue that it could create new opportunities for an energy revolution?
Sure. So you're right. It's very energy intensive to take CO2 out of the atmosphere, given it's so dilute in the atmosphere. And so the question becomes, where do we get that energy from? And I often will say, if we want to remove a million tons of CO2 from the atmosphere, it could take anywhere from a 300 to 500 megawatt power plant. And so when you think of direct air capture, you shouldn't think of it in a vacuum. You have to think about what energy are you going to use to do it. And the leading technologies today, both technologies, one, as I talked about, is based on liquid solvents, and another is on solid sorbents. They are very thermally driven. And in fact, so the energy distribution, about 80% is thermal energy and 20% is electricity. And so the first thing you have to think about is it's not all about power. It's really about how do we make heat today. And then if you take a little bit of a deep dive into the one technology like Climeworks, they can actually couple to waste heat. So low quality heat under or somewhere around 80 to 100 degrees C is adequate for their process, which means they can couple even to waste heat associated with the industrial sector. And that could be from a cement plant, it could be from an iron and steel facility. And so the other thing is we've also done a lot of work in my group on looking at direct air capture coupled to geothermal. So every geothermal power plant has a condensing unit before the working fluid goes back into the earth. And so a company like Climeworks or a technology based upon solid sorbents could be the condensing unit on a geothermal power plant. And so you don't have to think about a dedicated power facility for that type of direct air capture. Now, for the other kind, the liquid based approach, which is based upon a very strong basic solution to react with CO2, requires higher quality thermal energy. And one of the strategies that we've thought about with that is that in order to not lead to a competition between low carbon energy resources for displacing fossil energy, and then using low carbon energy resources for direct air capture, in order to prevent the competition, one thing that you could think about is, imagine if we are to increase renewable penetration into the grid 90% by 2035. Imagine if we could achieve those targets. If we do, we have to recognize that we have an invested infrastructure in natural gas-fired power plants in the United States today. So the fleet is fairly young. It's going to exist at a pretty large capacity. What we have today is going to exist through mid-century to a significant amount. And so one of the strategies that we've thought about is, imagine that if you could couple carbon capture to that natural gas powered fleet and use those plants, not just for, say, 10% baseload for the intermittent renewable energy, right, in order to kind of increase the penetration of renewables into the grid, but suppose that we were to use some of that capacity for fueling direct air capture. And in that way, we could use that stranded resources, those stranded assets, to fuel direct air capture. And then after mid-century, we would retire those units because they would reach their retirement age. And at that time, we would then have invested in the deployment of direct air capture, at that time, we would also have gone down the learning curve and realized lower costs for direct air capture, and we could reassess the energy portfolio and what's available for low carbon energy that you wouldn't be competing with, say, increased renewable penetration into the grid. So it goes back to kind of where we started today, and that is these things do not have to be seen as competing. The resources that are required to do deep decarbonization and carbon removal, if we can strategize, and also as Simon accurately and really elegantly said in his presentation, is that the guardrails and thinking about governance and keeping us in a framework that actually helps us to go through a transition that's just is very important.
That's very helpful. And Simon, let me ask you, in some of the work that your institute does in your conversations with civil society, how big of a part of the conversation when it comes to DACCS is the energy consumption factor? And is a lot of what Dr. Wilcox is talking about part of how they're thinking about the complex nature of this?
Somewhat, yeah. I think people are trying to look at the life cycle of what this might be and trying to imagine a pathway from where we are to what the promise of direct air capture is sometimes imagined to be. And of course, the energy load is a big piece of that. But I think on the civil society side, the concerns are more foundational and more fundamental. Is this just pie in the sky? Are we being promised something that will not materialize, and therefore this is a distraction from the work that needs to happen? And even if direct air capture turns out to be a thing, is it a thing at the cost of other things? So that is, should we be putting attention onto direct air capture when there's more urgent and immediate and clearly defined work that could be done right now? So I think that's the civil society message, which boils down to, don't let direct air capture and other forms of carbon removal distract from emissions abatement, distract from trying to prevent greenhouse gases from getting into the atmosphere right now. Okay, so that's a very real and reasonable concern. And at the same time, I think what Jen said is absolutely right. We need to think of doing things together. This is not an either-or conversation, it's an and conversation. So are there ways that direct air capture is compatible with the energy and other forms of revolution that we need to wean society off fossil fuels? What do those pathways look like? Right? And that's an act of imagination, and it's an act of coalition building, in addition to an act of kind of technical wondrousness to make that happen.
And maybe I could follow on with that a little bit too. I think it's really important for us to be honest about the accounting of the emissions that are really hard to avoid. Because to me, the primary role of carbon removal should be to offset the sectors that are really, really challenging. Not to, as Simon pointed out, if we see that we're assuming these very large amounts of carbon removal deployment by mid-century, it almost gives us a little bit of freedom in terms of not doing as much deep decarbonization today as we need to, because maybe those very large amounts in an irresponsible way are providing us the leeway to kind of be a little bit relaxed in the near term, and we just can't be. And it just goes back to, first and foremost, we need to decarbonize as much as we can everywhere we can, but then also recognize, even if we were to do everything, decarbonize everything we could possibly do, there's still going to be sectors that are challenging, like the agricultural sector, like some of the industrial sectors, and some aviation, some transportation sectors like aviation and shipping and long haul trucks. And if you add all of that up, it actually doesn't add up to such large numbers like tens of gigatons. It's a little bit smaller than that. And I think if we can tell that story a little bit more accurately, then we can go back to that conversation and say, true, CDR, if not done really appropriately, or if it's explained in this way that just seems too large, it's just reckless a little bit. And so, but if we explain it in a way of like, hey, it's going to be needed because of these sectors that are so hard to avoid, and those numbers are still pretty large. They're still on the order of gigatons. And if we need gigatons, then we need to start today.
I think one question for this the background of this webinar is, do we have the governance tools that we need, or can we already think of the governance tools we need to ensure that we're not going to do this in a reckless fashion, so that we avoid what's now being termed as mitigation deterrence, or the moral hazard question, and we focus, Jen, like you're saying, on the hard to mitigate sectors rather than giving ourselves some leeway. So before we turn to audience questions, why don't I start with you, Simon, on that kind of very broad question: do we have the governance tools we need to do that?
The governance tools exist, and this is an industrial process like lots of other industrial processes. It's a way to respond to climate change in conjunction with other ways to respond to climate change. The architecture to govern this stuff domestically in most countries and internationally certainly exists. Now, whether those tools will be deployed effectively, that's a whole different thing. I'm an academic. I can work with other academics and very adeptly describe a perfect world to you. But that's not the way that governance happens, right? Governance happens in the messy interplay of society needs and wants and political activity. And so we're going to get this wrong. That's inevitable. What we need to do is to imagine what right looks like and to kind of be policing that, to be working really hard collectively to try and get it as right as possible. Is that the wishy-washy enough answer, Michael?
It's a helpful start. Jen, something to add there?
I don't have anything to add. That's a really tough question.
And I may have asked it too broadly, but it's a good foundation for some of the questions I think we'll get into. Why don't I share an audience question, or a participant question rather? And Jen, this is for you. So an audience member asked, was the three times energy input versus point source utilization a specific technology or strictly thermodynamics? Do you have an opinion on whether sorbents are more cost effective than solvents for direct air capture?
Sure. So those energetics that I describe in my presentation are based upon combined first and second laws of thermodynamics. So it's really the lowest energy that's required to do a given separation. And anybody can do that calculation. It's in chapter 1 of my textbook, if anybody's curious on how that's done. And because it's an important calculation to be able to do as you're starting out in this space. And the only thing you need to know is what the initial concentration of the CO2 is in the gas stream, whether it's in the atmosphere or whether it's coming out of the exhaust stream of a power plant. But you also need to know what's the final purity that you need the CO2 to be in the end, because you have to recognize, are you going to use it on site, or are you going to put it into a pipeline or a truck, in which case it has to be compressed. And so you need pressure to do that. The final part that you need to do that calculation is what percentage of the CO2 in the stream are you going to capture? Those are the only three things you need, and you can calculate the minimum energy. And so that 3 times specifically has to do with the difference in the minimum energy associated with capturing CO2 from the atmosphere compared to the exhaust stream of a power plant. And so that's just the minimum. Okay. The important thing to recognize, though, is there's something called a second law efficiency. And that's the difference, really. It's the difference between, and not difference meaning subtraction, but just the distinction between a thermodynamic process, the best you can actually get to, versus a real process. And in a real process, you have efficiency losses. And so the second law of the thermodynamics or the second law of efficiency, it tells us how good the process is. And for all the direct air capture technologies that exist today, they're about 5%. And so the reason I point this out is because the second part of the question is saying, do you have an opinion on which ones might be better? And so what I would say is the second law efficiencies today are somewhere around maybe 5 to 8%. If you look at point source capture like Petronova, it's in the 20s in terms of percentage. And the more dilute your system is, the more inert gas you have to process. So it's really hard to kind of avoid those low efficiencies associated with dilute systems, but there's still room to improve. But roughly today, they're all about the same.
Okay, that's helpful. And this actually is a good segue into another participant question we had about the difference between DACCS and just point source CCS. So the questioner asked, given the presentation's references to energy consumption of DACCS versus CCS from point sources, what is the advantage of DACCS over CCS from point sources? In other words, why should we aim for DACCS before most or all point sources are covered by CCS? Would want to get some thoughts from both of you on that. But Jen, why don't I start with you again?
Yeah, I mean, I would say that it goes back to what we talked about before, in that the climate math is hard. And so we don't have a choice anymore. And we also recognize that there are sectors that are really hard to decarbonize. So we're going to need some CDR, and we need to do both today. But it's not an either or by any stretch. It just means that if we're going to continue to deploy things in the United States, for instance, like new natural gas-fired power plants, let them be carbon free. If we're going to, in China, deploy more coal-fired power plants, even if they're ultra super critical boiler technologies, and that's high efficiency, but let them be carbon free, because that is the situation we're in now, is that we cannot be emitting more carbon into the atmosphere. And it turns out even new builds and retrofits of fossil-based electricity generation, it's cheaper than direct air capture. It's less expensive to do that. And so we just need to recognize that first and foremost, we need to decarbonize, but we also need to do direct air capture at the same time. It's not that it's cheaper to do direct air capture, or certainly not easier. It's just that we no longer have a choice. And so in order to move forward in the best transition possible, we need to find opportunities where we can couple direct air capture, like I was saying before, to like waste heat opportunities, such that we're not competing with deep decarbonization. Like there are strategies that we can take to be able to do both.
Simon, I think you must have some thoughts here.
Not too much to add, except again, there's a math puzzle component to this, right? So putting the CCS on a point source is a way to slow greenhouse gas emissions into the atmosphere, but atmospheric concentrations of those greenhouse gases are still going to be rising, right? With direct air capture, there's a chance to turn things around and potentially at large enough a scale to be reducing the concentration of greenhouse gases in the atmosphere. We've already got too much carbon pollution that's warming the planet. And so carbon removal, in addition to helping us kind of offset hard to abate sectors, as Jen is talking about, the way that mainstream science is talking about this is a need to kind of turn things around, to actually start reducing ultimately the atmospheric concentration of greenhouse gases. That's what we mean by negative emissions, right? Negative emissions technologies are bringing down really the concentrations.
I want to move now to a question about kind of geopolitical considerations related to direct air capture, and kind of specifically knowing where carbon comes from and where it goes. Question is, could you explore and explain any reporting and verification complexities and their geopolitical implications? For example, the origin of removed CO2 will be unknown, and CO2 captured by DACCS may not be permanently stored within the capturing country's borders. Does this create unique challenges for DACCS governance? And Simon, why don't I start with you on this one?
Well, I wonder about that. I mean, in some ways, the amount of carbon being captured by a direct air capture facility is going to be easier to measure and easier probably to then quantify and verify through time than, say, the amount of carbon dioxide which is being stored in forests. And we already have international conversations about afforestation and avoided deforestation, and countries count avoided deforestation and planting of trees towards country-level climate goals. And so this to me doesn't seem an insurmountable challenge. I think the bigger challenge here is the challenge that we always see in climate politics, which is that the global south may be concerned about the global north trying to push climate action away from where it needs to really be taken, and where countries should be obliged to take action. And what I mean by that, of course, is that this idea of common but differentiated responsibilities, which has been at the heart of the international climate regime, doesn't go away as we're thinking about carbon removal, right? And so if direct air capture is shunted onto the global south in any sense, that is, the global north is saying, we will pay you in the global south to clean up our mess, and that's going to raise these equity and justice concerns. I mean, in some ways, as Jen mentioned in an excellent presentation, that might plague direct air capture less than, say, land-based forms of carbon removal. That is soils management and afforestation, bioenergy with carbon capture and storage, right, which really depend on growing biomass or doing something with soils, taking large amounts of land. Direct air capture could conceivably be sited in the countries that have been responsible for the carbon pollution in the first place. Right.
Jen, do you have, I want to make sure to check and see if you have some thoughts here as well.
The only thing I would add is when we take CO2 out of the air using direct air capture or even bioenergy coupled to carbon capture and storage, we do have to ask the question of what to do with the CO2. And the options are that you could use it for, you know, in a lot of the cases, for instance, with Climeworks, it's going into approaches that re-emit the CO2 back in the atmosphere.
Mm-hmm.
And so we really do have to think about if it's going to be a negative emissions approach, then we have to permanently remove CO2 from the atmosphere. So in both the BECCS case and the direct air capture case, where are you going to put the CO2? And so you could mineralize it, which doesn't, which is still a bit of a nascent technology, is reacting CO2 with alkaline rich rocks and minerals. Like there's a project in Iceland that's doing this, and in partnership with Climeworks, in fact. But there are also, of course, injection into sedimentary basins. So the same trapping mechanisms that have been trapping oil and gas in the earth are the trapping mechanisms that could keep CO2 in the earth. And so, but these geologic formations are not everywhere. They don't exist in all countries, and certainly not equal in terms of storage capacity. And so it could be that you have opportunities for putting a direct air capture plant in one region, but the question is where are you going to permanently store the CO2? And you might have to move it by barge, you might have to move it by pipeline or truck. And I think that those considerations are going to have to come into play when talking about governance and who gets the credit and who gets maybe, you know, is there an opportunity where somebody has a great storage site, but somebody else has the low carbon energy resources to do the capture, get it from point A to point B, and maybe it's income for that other country. But yeah, those things will have to be sorted out ultimately.
We have a question from a participant. How can the worry about direct air capture being captured itself by oil and gas interests be squared with the apparent need voiced by some that atmospheric CO2 utilization, especially EOR, is required to bridge the gap to get direct air capture started, at least in the US? And this comes from an anonymous participant. Jen, why don't we start with you?
Okay. I think a lot about this space, and it's tricky. It's a tricky one. I'll start with the positive. The positive is that we know when using CO2 through EOR that the CO2 that you use to enhance oil recovery is ultimately left in the ground. And when you look at the history of enhanced oil recovery in the United States, the first project was in 1972. And since then, we haven't had any CO2 leak. We haven't had any accidents. We know it's safe. We know the storage is durable. And so because of that, we know that there's assurance that when we use CO2 for this process, we know that that CO2 that we use is ultimately in the ground itself. But it comes at this other climate expense of producing new fossil and new carbon that enters the atmosphere. And so that's where it's tricky. The other piece that I think is tricky is when you look at how much carbon is stored in the earth through enhanced oil recovery for every barrel of oil that's produced. So typically these projects, you could see one of the projects being over, say, a 20-year time frame. And so over that life of the project, because it's what's called a tertiary method of recovery of oil. Primary just means that the oil's under pressure in the earth, you drill a well and it essentially naturally comes up. Secondary recovery is when you want to increase the pressure again because you've depleted the reservoir and you want more oil out, so you might just do water flooding. Tertiary is where you actually use CO2. And so now you want to recover more oil, and the CO2 is miscible at the depths of the formation where the oil resides. And it changes all of the properties like the surface tension and the density and the viscosity in it. So when you have a production well, both the oil and some of the CO2 will come back up, and the oil operators separate that at the surface and they put that CO2 back into the earth. And over the, say, the 20-year life of one of these enhanced oil projects, for every barrel of oil produced, about half a ton of CO2 is permanently sequestered in the earth. But then we know what happens is that that oil is refined, it's transported, it's then burned in an internal combustion engine, and it's emitted into the atmosphere. And so then the question becomes, in terms of carbon accounting, how much CO2 do you have to put in the earth in order to get a neutral barrel of oil out? And the answer is 0.6 tons of CO2. So the math isn't that hard. It's only 0.1 more than what they do today. The tricky part with this is that when you look at the scale of enhanced oil recovery in the United States, the utilization market for CO2 in total is about 80 million tons of CO2 every year in the US. 72 million tons is associated with this industry, enhanced oil recovery. And most of that CO2 that's used for EOR today is mined naturally from the earth. And that number is about 60 to 65 million tons of CO2 every year that's naturally mined from the earth. So there are domes that, very similar to how oil and gas resides in the earth, we have reservoirs that are actually storing pretty high purity CO2. And so those domes are just tapped into and naturally mined to bring the CO2 to the EOR sites. And so the challenge that I have with the oil and gas industry is that that's a pretty large CO2 market, 65 million tons. So you build one direct air capture plant at 1 million tons. And it's like, but you've got to be careful because that's a drop in the bucket, right, compared to, you know, what's actually done today. So it's just, we have to be real about what the industry looks like today, and that we have to transition and take steps and maybe stop mining natural CO2 as a first step, leave it in the earth, and actually recognize that we have plenty of anthropogenic CO2 that we're creating every year. And that maybe we just kind of transition into that. So I'm not saying we shouldn't do EOR. I think that it could be seen as a bridge in the near term, eventually weaning ourselves off of it ultimately, because it's not necessarily a sustainable way to meet climate goals, is to put more carbon that's new into the atmosphere. But I think that there needs to be a recognition of how it's done today. The other thing I'll just add briefly is that another role that the oil and gas industry could play is in the area of synthetic fuels. And so when we look at enhanced oil recovery or even conventional recovery of oil and everything, not just oil, but natural gas, what do we get from transportation fuels and a lot of petrochemicals like plastics and different nylon and polyester? We all rely on these types of products. But it turns out we can also use CO2 and green hydrogen as feedstocks for making these same products. And a lot of the intelligence and labor force and experience in doing that could be leveraged from the oil and gas industry. And so there's a lot of ways that we can think about a transition that would decouple us from our dependence on fossil fuels and instead using CO2, anthropogenic CO2 as a feedstock for these processes. So that's a long answer.
No, but it's super helpful, Jen. Thank you. And I want to follow that up with a question to both of you about this and EOR. I know Simon's Institute has been doing some thinking on EOR as well. Is it also possible to conceive of a scale up for direct air capture that doesn't involve EOR? And if we're thinking about both in the US and then the ramifications internationally, and could we think of markets for direct air capture, a scale up that doesn't involve the oil and gas industry directly? I know there's a lot of thinking about the potential routes we could go with various parts of the oil and gas industry. I'm wondering if there's also possible pathways that don't involve those groups. So Simon, why don't we start with you for a second, or for as long as you'd like.
Yeah, well, just a second, because I think Jen's answer, that was fantastic. I mean, that level of detail, I think, just doesn't normally, it's not typically apparent in the conversation about this stuff. And so I think what you gave us there is just enormously important in terms of how one thinks about engagement with the oil and gas industry on these issues. I'm just going to say a high-level thing just to add to the conversation. The oil and gas industry has not been a good and credible actor on climate action. So for many folks in civil society and in the policy communities, that needs to be the starting point. The oil and gas industry over and over again has talked about going green, has talked about becoming not just fossil fuel companies, but energy companies and having big renewable energy portfolios. And over again, those sorts of promises have not panned out, they've fallen over. And oil and gas companies tend to spend a lot more money on getting new oil and gas out of the ground than they do on making transition. And so, so much of this is about holding those actors that need to transition and need to be a part of societal transition into a new form, holding those companies to account and making sure that they really are credible actors, that they're stepping to the table, not just to delay action, but to actually be a part of the action, right? And that's a difficult thing, Jen, I would say, to wrap our heads around. I can imagine large-scale direct air capture absent engagement with the oil and gas industry, but the technical pathway to large-scale direct air capture looks a whole lot easier if the oil and gas industry is on board, given their technical expertise.
Jen, I want to give you space there if you want to follow up on that as well.
Yeah, I mean, what I would say in terms of transition, absolutely, I think that there is a way to transition and involve, we need to put carbon in the earth on the order of gigatons. And that carbon, when you think of the legacy of carbon, it was sourced from fossil fuel to begin with. So to me, it makes sense that we want to put it back where it came from. And the best industry to be able to do that is the oil and gas industry. And so when I think about where first to put it, I mean, I think of the Permian Basin, I think of the Gulf Coast, those reservoirs that are recovering oil today don't have to. And the wells that are there today are class 2 wells. So not as difficult in terms of permitting, for instance. And so if the wells are already drilled and the infrastructure already exists, I just wonder, can we think of a transition where these companies are dedicated, having projects that are dedicated geologic storage, not having to do with bringing more oil out of the ground. The other thing I would say is, as I mentioned, the natural CO2 that's been mined since the 70s, what's happening to those domes? How much vacancy have we left in them? They are obviously a great storage opportunity for CO2. Can we put the CO2 back where it came from? And so I think that absolutely, who knows the geophysics, who knows the engineering of the subsurface better than that community? I don't know. And so I think that they have to be able to play a role. And if the policies were in place to economically incentivize this industry, putting carbon back into the earth, then that could be quite hopeful, I think.
We have 3 minutes left officially, but with your okay, I'm going to push us just a few minutes over. I have 2 more questions I want to jam in here. One has some relation to what we were just talking about. There was an announcement by United Airlines last week about their intention to be involved with some forms of carbon removal to account for some of their emissions. I was wondering, Simon, maybe you could give us just a quick overview of what that announcement was. And I know the Institute had some thinking on the dynamics of that, and then I'd like to hear from Jen as well.
Yeah, the United announcement is interesting. It's part of United's push to become carbon neutral by, Jen, do you remember 2050? I think they're talking about,
yeah.
right? So. Which is a pretty aggressive announcement from an airline. And what they're suggesting in part is that this carbon neutrality is going to be purchased, if you like, in part by a multi-million-dollar investment in direct air capture. And so we put a blog post out from the Institute, which says, in part, wonderful that United's paying attention to direct air capture. Early stage investment in what could be a very promising technological pathway is super important. But investing in direct air capture on the front end is not the same as actually investing in the capturing of carbon dioxide from the atmosphere and its long-term storage. And so, we should separate those two pieces of the United announcement. Investing on the front end is important and good, but quite different than actually putting money over the long term and drawing carbon out of the atmosphere.
Jen.
Yeah, so it's 2050. I just checked.
Great, thanks.
Yeah, and I mean, my feeling is, and if you haven't read Simon's blog post, you should. It's excellent. And but my feeling is you also, when a company makes a pledge like this, and also recognizing that a company like Oxy Low Carbon Ventures is also already making an investment in that same technology, we want to be careful about what does the approach really look like. It would have been nice to just have a little bit more transparency. And so if you're an airline, we all recognize that the supply chain is aviation fuel. And there, in my mind, if you're coupling with direct air capture, there's three paths to getting there. And it goes back to what Simon was talking about. Like there are different paths that we can take, and some are better than others. And so if you think about, those three paths, what do they look like? One would be if you were to take the CO2 from the atmosphere and react it with, say, green hydrogen to produce a synthetic fuel. But if you do that, you have to ask yourself, where are you getting the low carbon energy for the electrolysis for the hydrogen? And where are you getting the low carbon energy to actually put into making the fuel? Because CO2 is not very reactive, and that takes energy to put it back into a fuel. The second option would be that they're simply they're using direct air capture to, say, purchase or removal in order to just simply offset their emissions footprint. In that case, then I would be careful, because right now the approach to that project is in the Permian Basin. It's already really specifically been outlined that they're using the CO2 for enhanced oil recovery, and that's partly why Oxy Low Carbon Ventures is also supporting it. So to me, that pathway has a hole today, but maybe if it could be patched with United in a partnership, then I think that would be a wonderful thing. The third is the one that we've talked about. If you put 0.6 tons of CO2 in the earth for every barrel you take out, you have carbon neutral oil. And that again goes back to the tricky part that I talked about, because it's so far from making any kind of dent because of the way that the industry is today and how much dependence is on mined natural CO2. And so that one to me is a tricky path forward. And so I would just want to, number one, I don't want to be negative. I'm very excited that there's investments in direct air capture. We need it. We need people to lean in today to make it affordable for everybody later, because it's just a tool in the kit that we're going to need to rely on. But I also just what I don't want is I don't want PR to be used as something that polarizes the community when in the end, we all just want the same goals to meet climate goals, right? And so we don't want poor communication to take place now to only have an excuse to stall. And so I just think we really have to be careful.
Thanks both. And so I want to finish on I think what we'll agree is a super important question, but it's broad and there may not be a good initial answer. But Simon, you mentioned in your presentation the need to keep environmental justice considerations at the fore while we're thinking through governing direct air capture, all aspects of governing direct air capture. So my question is, how do we do that?
Thanks. So that is the final question. I'll give just the highest level answer, right? And it's to make sure that environmental justice voices are present in the assessment of these technological pathways. And there are two clear things that need to happen in order to do that. It's to make sure that folks identify who the appropriate communities are, right? At all different scales, from where these facilities might be sited through to the global conversation that needs to take place about where direct air capture fits into climate response. And then money needs to flow to those communities so that people have the capacity to meaningfully kind of step into the conversation. Right? We overtax environmental justice voices by always asking folks who are already overstretched to contribute to yet one more line of work. And so I think that there's a big resource question here. we need to make sure that money is flowing to the communities that need to be a part of this conversation.
Jen?
I think that's a great answer to a hard question.
Okay, great. Listen, thank you both for your time today, both in putting together the presentations that helped us be the foundation for this conversation, and then taking part in answering some questions from C2G and as well as our participants. And we hope this event was useful for understanding some of the basic concepts around direct air capture for our participants. For more information, for those of you that are interested, you can go to the website for C2G, which is c2g2.net. We have a survey that'll pop up on the screen after the webinar is over that you might take a minute to fill out, just to tell us how you think we're doing in terms of our goals of communicating some of this information. And I want to thank my colleagues behind the scenes that helped make this webinar run smoothly. And thanks for joining us today, everyone. Hope you have enjoyable, relaxing holidays with some actual relaxing, and see you again in the future sometime soon. Thank you.
Thank you.
Thanks, Michael.